All right. Good day, everyone. Hopefully, your spring break is really, really good. Chill, all that, then some. In this presentation, I'm just doing some factor review for you to get prepared for your quiz when you come back for spring break. In addition to helping you with your statistics review as well. Again, the beautiful thing about spring break is that we don't have to see each other. I don't have to give you nothing new, which I couldn't do that in a way. Just review what you've been taught. I gave you guys work to do over spring break. Even if you was absent, you had something to do over spring break. Um, I told you guys when you come back for spring break, you will have a quiz. I need to make sure that your factor is on point. So let's do it. All right. So I'm do reviewing of factoring, but this is my last time going over factoring, y'all. After that, if you don't get it by now, I'm moving on past. I'm not wasting no more time. I'm not teaching it no more in class for none of you. No. You're going to watch this video. You're going to practice the factor techniques, and we're going to move on. Going over the statistics facts and probability review. That's all I'm doing. So again, this is just to give you some additional practice and some more support. I am not, hear me, I'll probably post one Kahoot on Factor, which I already done, but I'll do it again. But after that, that's it. You gotta learn how to do it. Alright, class reminders. You guys know you will have quiz weekly. There's no crazy points thrown to save you when you fail. Fourth 9 weeks is by skill. Homework must have quality, although I'll give you quantity. Absent students must complete online assignments, and when I receive paper assignments, unless I choose not to post nothing new for you to do. Alright? Now, if you sick, you gotta bring that documentation of your sickness. You can't just turn the stuff in when you feel like it either. You have to be on time with it. Because this is the end of 9 weeks. I can't really save you for anything. So make sure you turn the work in on time. And make sure you bring your excuses in a timely manner. Alright. So this is what we do for the factor and the factor and everything else. You're going to pause the video, you're going to work it out, and then you're going to play the video to compare your work. Alright? So why don't you try this one? Pause the video and factor this stuff out. By now, I know you have worked the problem out. If you have not factored it by yourself, you need to pause the video and do so. Otherwise, let's go ahead and go on with it. So when you see this kind of binomial, the only thing you could do is a greatest common factor. Many of you guys oftentimes miss the simplicity of this. So we know that the greatest common factor is 2 because we get 2. And then what's going to be left on the inside is going to be n minus 2. To check your work, you're going to use distributive property to check it. You see how I'm drawing my arrows? So 2 times n is 2n, right? 2 times negative 2 equals negative 4. And so that's how I know that my factor is right. So this is to show proof that you got your factoring together. And that's just that. Nice, clean, ready to go. Again, this is that greatest common factor, GCF. You guys should spot greatest common factor by now. Again, let me stress this enough. I am not going over this with you. If you don't have it down to a science, we've been doing this since August. Moving on. Again, I wish I could solely just test you on your statistical abilities, but sadly, I cannot do that. So, Oh, I forgot my dots in the previous problem. So you guys, that problem we just did, that was it. Nothing more, nothing less to it. Now, this is a trinomial. Why don't you factor it and try the methods that we did on the previous problems? Pause the video now. By now, you should have worked the problem out and you should have it all situated. If you have not, please pause the video, do this problem. Otherwise, I'm going over it. All right, so here, I know it looks like I could do a swing method, but I know if I do that, I get k squared minus 40 plus 50. And I know for a fact that cannot be factored, so I can't do that. So I won't do that. What we did in the previous problem, we look for the greatest common factor. All these got 5 in common. Because when you divide 5 on all these integers, you get k minus 8k, well that's k squared, minus 8k plus 2. Leave your parentheses, and because you use a 5 to factor out everything, just put it on the outside. Now, I could see if I could factor this on the inside, but however, I know for a fact that I cannot factor the inside because there's no number multiplied together gives you 2, and you add gives you negative 8. It will not work. But to verify my answer, all I have to do is just distribute 5 into everything that I have done so far. So 5k squared minus 5 times 8, that's 40k. 5 times 2 is 10. Guess what? Got my answer correct. And let me put my dot on here. And that's how I knew that that could work. So my dots are done. I'm finished. I don't have to explain no more what to you. All I know is look at the greatest common factor and pull out and keep going again. I'm not doing this with you no more. If you don't have this down, this is your downfall. It is not mine because I have explained it to you. We practiced it. I gave you quizzes over it. You need to sit down and study. Work these problems out like I instructed you to do so. I am not providing you a Kahoot at all because I gave you several Kahoots of what's going on. It's a memory game. That's what you guys are trying to do. And of course, when you come to my quiz are much more than just a memory game. So try this problem using the same technique. Pause the video and try it out. When you're sitting there just writing problems down and trying to remember what I have done, that's not going to work for you. So let's not play the memory game. Let's work the problems out. Do it right now. By now, you have completed this problem. You have factors. You did the greatest common factor. You did a lot of work. If you have not done so, please, please, please pause the video. So, did you realize that the greatest common factor of these three integers was 8? Also, did you realize that all these variables, had at least x squared in common? You have 2 x's here, you have 3 x's right here, and then you have 5. So that just means that I could take two x's from each of these variables. And so with that being said, it's going to be not just a, it's going to be 8x squared. Now, what's going to be the inside? 8 times what gives me 72. 9. How many x's do I got left? X's to the power of 3. And we know to get 72 is to get negative 72, 8 times negative 9. But I'm left with 1x, so it's going to be 9x. 8 squared times what gives me negative 80x squared, which is just 10 because I have no x's left. Okay? Now, let me give you a little bit more details because I want you to get every detail possible. Because again, we're not going over this anymore. So, ax squared times 9x cubed. So, we know 8 times 9 is 72. And when you multiply exponents, you add them. So 2 plus 3, not 2 times 3, that's 5. Because again, when you multiply, you add the exponents. Okay? So 8x squared. Let me change the color because I want you guys to see everything, every little detail. X squared times negative 9x. When you multiply this across, you get negative 72, and you get x, because this x by itself has a power of 1 to it, so 2 plus 1 is 3. Again, every x you see by itself has an exponent of 1 or a power of 1. Power and exponents means the same thing. Alright, let me erase this right here. And ax squared times negative 10 equals negative 80x squared. And that is not my answer. I don't know why I'm tripping here. I'm sorry. I'm tripping big time. 12 times 7. 12 times 6. Okay, good. I was correct. So that's not going to... So this is incorrect. So this is your correct answer right here. Alright? That is incorrect. This is correct. We have shown the work for it. Why it's true? Could we multiply all of this to check our work? And we got what we needed right here. Okay? And we double checked our work from here. So yeah, that answer I put together right here, that was incorrect, but this is correct. All right, and that's the reason why I want you guys to check your work. You see how I checked my work and all the details? That's what I need for you guys to do. Because see, having not checked my work and have we not put the good thought of it, we could have possibly got that wrong. So just be careful. Make sure you check your work. Make sure you show all the little details. Make sure that your stuff is correct. If you need to draw X's, like how I've been doing, that should help you out as well too. All right, so let's move on. Now, let's try this problem. You pause it and you try it out. All right, I take it that you have got this down to a science. So you realize that the only thing that they have in common was the K's. And you realize each one of those, each part of the binomial has at least one K that you can take out, or at most a K to take out. So it's going to be K squared times, or K times 7K plus 9. Now, let's make sure to double check our work. We did it this way. We pulled out, we did this, so let's check it. K times 7K is 7K squared, which is what we're doing. We're doing distributive property. K times 9 equals 9K. And that's how I know my answer is correct. Boom. Not bad, huh? Pretty easy. Again, the GCF is a very essential piece. Very essential. And by now, you guys should know how to, find the greatest common factor, just like we've been doing. And some of the hard stuff that you're going to be doing involves the GCF. You have to instantly recognize, oh, GCF, and then I could determine can I factor, yes, no, and keep going. All right, let's try this yourself. You should now do this one, so you try and knock it out right quick and get back to me. All right, I'm thrilled and believe that you have finished this factor. Now, if you not have done so, pause video and do so. We know for a fact, when you guys got this down to the science, you realize that -9 times 2 gives you -18, and you know that -9 plus 2 gives you -7. And that's how you know your answer is correct. Now, if you want to check your work all the way through all this, you can do it. Now, for this, I don't ask you to check your work because it's very straightforward and easy going. But in case you want to just double check yourself, which again, when you get to this part right here, this is the easiest piece to do. So this one I'm about to show you is a little unnecessary, but we're gonna do it anyway. So when you multiply here using your formula method, x times x, that's x squared, x times 2x or 2, sorry, equals 2x. Again, this is not something that you need to do. This is just something I'm doing just so you can know how to double check your work. I may ask you in the quiz to double check it in terms of this foiling method too. So let's do this one. Negative 9 times x equals negative 9x, and negative 9 times 2 equals negative 18. All right. So you got all your pieces together, and let's just combine like terms. So we get x squared that's negative 9. So 2 plus negative 9 is negative 7x. All right. And then you get negative 18. And that's how you know your stuff is correct. It's just that simple. And there's anything you misheard, just slow replay the video, because all I did was x times x, which gives me x squared, x times 2x, 2, which gives me 2x, 9 times negative x, is negative 9x, and negative 9 times negative 2, negative 18. Combine my 2x to the negative 19, negative 9x, I got negative 7x. And that's how you check your work to know that you are completely correct. So I gave you a lot to consider. So again, you should know how to factor inside out. Now, try this video. This problem. Work it out, then come see me. All right. So you realize this is sweet method. So you go 2 times 21, and you multiply. You rewrite. So that's b squared plus 17b plus 42. I got 42 because I multiplied 2 times 21. So front times the back, and then I rewrote it. Now let's do the thing that we love how to do. Where two numbers multiplied together gives me 42. And then when I add them numbers again, they give me 17. And I could honestly say 14 times 3 gives you 42. And 14 plus 3 gives you 17. Alright, so we got that part. So let's put our stuff together. X plus 14. Again, you could put x plus 3 in the front if you want to instead of x plus 14. Or not. The order does not matter. And then you put x plus 3. So again, the order does not matter for here. You could rewrite this any way you see fit. So it could be x plus 3, x plus 14. However you want to do it, that is fine. As long as you got x plus the numbers that we found that works. Alright, next. Take a, whatever in front, and then divide it by 2. So we divide by 2. So 42 divided by 2, that does give you an integer, x plus 7. And then 3 divided by 2, that doesn't give you an integer. So you gotta swing that 2 in the front. Swing it. Swing it. 2x plus 3. Swinging it like you were driving the car on airline. And so your final answer should be just that. I know I got a habit of using X instead of B's. That's just something that many of us mathematicians prefer to use a lot. We just love the letter X. So if you saw me use X instead of B, that is fine. If you used to do this on the test like I just did, you said X instead of B, I will give you full credit for it. I won't hold it against you. But just to, show correctness of it, although it is correct, let's make sure we got our variables, use the correct variables. Again, I'm more concerned that you know how to get the numbers to work in your favor. And again, I would not be too in my feelings if you use X instead of B. I totally understand how this works. Again, the order here does not matter. So you could write B 2B plus 3 in the front if you want to, or you put it in the back. I chose to put it in the back, but that is correct. I'm impressed that you guys got this down. I know some of you guys was like, Mr. R, you tripping. Why are you not using B instead of X? Again, that's just a habit. If you got into that habit, I want to hold you accountable to that. None of the other mathematicians will hold you hostage of that either. All right. Now try this particular problem. But now you have did this, and you have not. You need to pause the video and do it. So let's go ahead and get our factoring on. Of course, this is a factor by group because you see four um, terms. So let's do the term to the left. We realize that we give a 3p squared out because we both know that that has a 1, 2, 3p's right here, and then 1, 2, and you realize that you could take off 2 of the p's right here, and you could take 2 of the p's from this one as well. And so when I took off 2 of that p's in particular, that's going to be left with 4p minus 7. All right. So that means that my inside of this right here should also match the other side. So here we realize that we have a 7 that we could pull out. The greatest common factor is 7. Again, all this is all about GCFs, and many of you guys need to have a full understanding of the GCF. So 7 times 4p gives me 28, as 7 times negative 7 gives me negative 49. And we know we are correct because look, we match here and we match right here. So with my final answer being 3p squared plus 7, because I took what's on the outside, and 4p minus 7 was in the inside, and it has to repeat. And you can write these any other way that you want to. I always prefer my outside and my inside. That's how I write my factors. And it looks like they wrote their things the same way. Again, you could say 4p minus 7, 3p squared plus 7. Does not matter. And that is us getting our final answer to it. I think you guys got this one down to a science, so let's move on. All right. So you guys do this one. I'm not going over this one itself. No. You're going to do this one. And I'm just going to give you the answer. I'm going to move on. You take care of the missing pieces. Welcome back. By now, I know that you worked the problem out, you got all the details that you need, and you realize that the answer was this. Now, I did say I was not going to do that for you, but I feel like I needs to be nice. So I would be nice on this one. So here, This involves the greatest common factor situation I was warning you guys about. So they all have the greatest common factor. So when you pull out a 3, well, I'm not going to do all this for you. You just realize that the greatest common factor is 3. Matter of fact, I'm going to leave it as that. And then you figure out the rest. You figure this part out, what's in the inside. I'm not doing this for you. You just realize that the greatest common factor was 3. And the answer is already there for you, so you get from here to there. And I already gave you a piece of help. So again, I'm not doing the rest of this. I gave you the greatest common factor. You keep it going. All right. Why don't you try this problem out on your own right quick? Pause the video and try it. By now, I know that you have worked this problem out. Because this is dealing with the difference of squares, just take the square root of these integers. So square root of 121, you know without doubt is 11. And the square root of 25 is 5. So with that being said, you're going to get 11n minus 5 and 11n plus 5. Now, that is the answer. But of course, if you want to see how I got that, like I said, I just took the pieces and put them together. But to make sure that my answers are correct, I'm going to go from the factoring stuff, or the distributive property, up to here. Now watch me work backwards. So, using my distributive property, well, foiling methods, let me multiply 11n times 11n. And when you multiply that, you're going to get 121. But remember, the n's, because you're multiplying them, you add them together. And remember, when you see n by itself, it has an exponent of 1. So that's going to be 1 plus 1 equals 2. So 121 n to the power of 2. So 11n times 5, that's just 55n. But negative 5 times 11n equals negative 55n. And then negative 5 times 5 equals negative 25. Now I have did my foiling method all the way through. Things could cancel out. So those negative 55n and that positive 55n cancel out, leaving me with this. And this is how I know I am correct. Because you are left with 121n squared minus 25. And that's what you started off with. And this is how I know my answer is correct. So I have already did it. Let me put my 3 little dots again. So I'm done. Boom, there it is. No more work. No, nothing extra left to do. I'm done. And that's only when you're dealing with exponent of 2 by itself. You see how there's no other n's right here? And how these are squares, square roots, perfect squares. That's what they are, perfect squares. And that's how you get that done. Again, there's no GCF involved with this one, so that's none. And you could just tell looking at it, because they 25 and 121 has nothing in common other than just 1. Alright, cubes. Now this is something with cubes. Cubes. Yes, cubes. So you look at this, they have nothing in common. So that's no GCF allowed. But this is cubed, so you know, 64 has 4 repeating 3 times to give you that 64 because this is cubes. And then you have 3 A's. Now I want you now to pause the video and try to do this one with the help I gave you. Pause it and do it. Alright, but now I know you should have in your front parentheses a plus 4. And by the way, if you have not done this, pause the video now and do this on your own. So a plus 4 in the front, and then here you're going to have a squared right here because you're going to have 2 a's in the back. And then you're going to use the 2 4's in the front, which is going to be 16, or 4 squared. 4 squared is 16. And then in the middle, you'll multiply 4 times a, which is 4a. But what you're going to do is change your sign. So this is going to be negative. Now, how do y'all know that this is correct? Remember all the factoring stuff that I did with the foiling and seeing you can't come back right here? Well, let's do it. So, I'll multiply all this into here. And let me erase because I know some of you guys need the level of neatness to all of this. So let's do it. So a times a squared is a cube. A times negative 4a is 4a squared. And this is multiplication. And then you're going to get a times 16, which is 16a. Let me rewrite this because I need for y'all to see this well. Oh, it's so hard to do this in the mouse. Alright, everybody good with this? So that's all I did so far is multiply. I did distributive property and multiply stuff. Oh, that's negative 4a. Thank you for whoever called that out to my attention. So let me erase this. Negative 4a. Alright, so we did the for the method for the a into everything else. Now let's do it to the 4 into everything else. So, doing dark blue. So I'm just drawing my arrows just because you will see where I got everything from. So it's going to be 4 times a squared, which is 4a squared multiplied. And then here you get 4 times negative 4a, which is negative 16a. And it's gotten a little bit harder to write, so let me rewrite this. I know y'all, I'm sorry you tripping, but I'm trying so hard to write this in a way that it could be understood. So 4 times negative 4a, which is negative 16a. That's better. And then 4 times 16, which is 64. Again, yeah, I'm so sorry. It's just getting all this together. There we are. All right. Now, since we did the FOIL method, let's combine terms and stuff, and let's see what cancels out. So let's look for it. So negative 4a squared cancels out with a squared. Negative 16a cancels out with 16a. So you are only left with a cubed plus 64. And that's how you know that your answer was right. And we was right here. So that's how we know we right. Bam. So that's it. We done. We good. No more additional work. We have did all of that work. Let's move on. All right. I want you to try this problem on your own and double check it. I'm not going. This one I won't do too much on because the steps are exactly as the same as the other. Again, this is cube. So try this. Do it. Pause that video. By now you have did this problem. You have not paused it and do it. So you should have gotten this answer. The only thing that I will explain to you, do not forget this sign change. This is going to be positive instead of negative. If this is negative, this is positive. And the back is always, forever, ever positive. Doesn't matter if I'm dealing with positive or negative. This is always positive. The middle changes. So use your FOIL method to double check your work. I trust that you did. And again, I'm not doing the details of this. I'm going to leave it as this and move on. All right. So that was all our factoring stuff we don't did. And I just want to make sure that you got it together because when we come back for this break, it is what it is. Statistics, given the facts. So on your quiz, you just have to recall facts. So two pieces of information. Data is a number that tells the story. A statistic, using data to inspire change. Again, you're using data to inspire change. We watch the news because we often want to see what's going on around us and see can we make a slight difference. Even as a teenager, you think about things to make a decision. You use data to see about the decision process. All right? And these are two things you have to know. All right. You must, by now, y'all should be familiar with the precise definition of mathematics. It is the technique to teach, learn, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. Those are things that that's the precise definition of mathematics. You must know this because you have seen this since day one. So this 4 9 weeks, you gotta have it to a science, have it to perfection. All right, let's look at the statistics definition. Statistics, and again, these are precise definitions, so let me make this clear. These both are precise definitions. In the previous example, we talked about a statistic. This is the precise definition of mathematics and the precise definition of statistics, which is the statistics is the technique of collecting, organizing, analyzing, and interpreting data to make decisions. We do that. You guys should know how you satisfy this definition. You use statistics every single day, you know. And I'm not going to go no further into that detail because you know it. All right, a statistical question is one for which you do not expect to get a single answer, which I told you to only give me this statement. And this is what I want you to tell me. A statistical question is one in which you don't expect a single answer. I'm okay with that. The rest of this, I'm expect you to know this in a different time. So this that I'm highlighting, this could wait to later. But this I circled, that's what I'm looking to see at the end of the spring break. Alright, such a tendency is to help you find the middle, the average of a data set. So, only thing I want you to worry about is what I told you to write down in your notes. So I want you to know this. I want you to know the data set. I don't care for the rest of these, because these, you don't need to know those. Well, you do, but those are not things that I would test you on. Like in terms of the definitions. Now, let's talk about the fathers of probability. Blaise Pascal and Pierre de Fermat. These are people who we have to know. These are the fathers who did it out. Have it not been for them, we would have not had the statistics that we know today, or even have the interpretation of it today. Probability laws. If anything, I want you to worry about this the most. Probability or A and B. So of course that means that two events cannot happen at the same time, so we have to find the probability of one or the other. This complement events, not really. I don't want y'all to know this at the moment. Well, have it mastered. Let me say that. So that's not important. So we're gonna scratch that out. But that is. All right. So you gotta spin them. Spin them once. What's the probability of it being even or given the probability of 4? I mean, or greater than the probability of 4. So let's look at the probability of it being even. So if it's even, you got 6 and 4, so that's 2/3, right? Plus, greater than 4, 5 and 6, which is greater than 4, that's 2/3. Again, it cannot be greater than 4 and even at the same time. It cannot be both. So it's or. So when you add those together, well, I'm tripping about something. Probability of even is 2/3. Probability greater than that is that. Okay, that's right. Or is it? So what do you guys try to figure this one out for yourself? See, can you catch me in the criminal at? So why don't you try it? What's the probability of it landing on an even number? You got 4 is an even number and 6. What's the probability of it's greater than 4? So you got 5 is greater than 4. 6 greater than 4. So let me ask you this question. Now, although for this question this is most correct, but let me ask you this. Could we add both 2/3 together? We get 4/3. Could this be a true probability? Could this be true? Could this be a true probability? We know that probability is between 0 and 1. So I want you to find it out and call it out to me. All right, flipping the coin. What's the probability of this being heads or tails? Try this one. By now, I know that you got the answer. I know you got it down to a science. But if you have not worked this problem, you need to work it out. So for it to be or, remember it's one or the other. Because you flip a coin, can't both be heads and tails. It's one or the other. So probability of tails is just 1/2. The word or, maybe I didn't explain this to y'all. You use plus. Heads is 1/2. So 2/2 makes a whole. When you're using the word or, we have which represents addition. In a statistical word, we also use or as a union. So union 1/2 plus 1/2 union 1/2. This is what this represents. That's what that's saying. So the U shape is union, but we won't talk too much about that for now. Only thing you gotta worry about when you see or is adding the probabilities like that, and that's what I'm gonna test you on. Ooh, you guys, try this one on your own. And let's see what's up. All right. So what's the probability of it being greater than 3? The probability of it being greater than 3, you got 3 out of 6. And remember, because it's or, it means plus. If it's less than 2, so that means that's just 1/6. So 3 6 plus 1/6 is 4/6. And if you simplify 4/6, you get 2/3. So if you did this, good job on your own. I know I should have told you to pause the video if you not have done so, but I trust that you got it down to a science. Alright, so we're dealing with independent events. Only thing we are saying is when the probability of both events occur and when they are the product of the probabilities of events, so meaning that they multiply together, they equal each other when you multiply them together. I know you like, Mr. I don't get it. It's just so weird, which it is. You're about to see some examples that are more simpler than me saying it. Alright, so let's do this one. So, in the experiment, the probability of A occurs is 3/5. The probability of B occurs is 5/9. And the probability that the events A and B occurs is 2/9. Are they independent? So to determine that, so you get A times B, which is A and B, 2/9. So that means that when you multiply them separately, they should equal 2/9 for them to be independent. So 3/5 times 5/9. Are these independent events? And when you multiply them, let's see. So if I'm multiplying, I know that 5 cancels out, so that's going to be 3/9. So are they independent? Does 2/9 equals 3/9? As much as it should be, sadly, it's not. So therefore, it's not independent. So 2/3 does not equal 3/9. And that's the simplistic part of it. It's just that simple, y'all. It's not as hard as I make it to be. So that's not it. And that's essentially, that's all you have to do. So let's go over this in detail. So you see the probability of events of A and B, right? So A and B have to equals 2/9. It equals 2/9. Now, what they telling you, does A times B gives you A and B together? That's all they are asking you to do. So, does the probability of A and B, and the word statistics, and is used as a intersection circle. So A and B, does it equals probability of A times probability of B? So when you multiply A times B, does it equals A and B? All right, let's do another one so you can feel a little bit better. So do as we did and see, do you have independent events? Try out. But now I take it that you have figured this out. So 5, 6, because that's the probability of both A and B. And again, that intersection notation means and. I'll explain that to y'all so much better in detail when we come back. But it's just A and B. Does it equals A, probability of A, times the probability of B? That's what you're trying to figure out. This probability of A and B equals probability of A times B. So that's 5, 6. So probability of A is 1/4. Probability of B is 2/3. We multiply those across. Do they equal 5, 6? Just looking at it, I don't see it equals 5, 6. I don't see it. So it just can't be. All right, conditional probability. Again, we see probability A and B. All I'm saying is probability of A and the intersection of B and the probability of B. So again, this is another easy problem. Probability of A and B given A given B. You just gotta pay attention to what's being said. All right. Let's move on. All right. In the experiment probability, A occurs 4/5. The probability of B is 6/7, and the probability of this A B occurs 2/3. What's the probability of A given B occurs? So to do this problem, get your A and B, which is 2/3, and divide by, because it said given B, when you say given B, divide by 6/7. So I'm not going to do this last part for you. Well, why not? So keep, well, not all of it, change, flip. 3 times 6 equals 18. 2 times 7 is 14. So 14 over 18th. You put that in the calculator, you should get some decimal point. But make sure you put it in the hundreds place, so it's going to be 2 numbers behind the decimal point. So, matter of fact, I could do that for you. What's the calculator? When one of you guys got it, and you can move on. So 14 divided by 18. That's a 77%. That's all you have to do. Or you can run it out to 78. Best around 78. Right, just like that. Moving on. I want you to try this one by yourself. I'm not going over it. I want you to try this one because it's very simplistic. It's not really nothing hard to do. It's just get your A and B divided by the probability of B. Nothing hard. All right, y'all. That's pretty much just that. We are done. This is it. Hopefully you use this time to get this right. And I wish you guys the best of luck. All right.